Hello, everybody. I'm John McClune. I lead the technical services team for Wolfram Research Europe, where we do projects for customers using the Wolfram technology. But actually, what I'm going to be talking about today is a side project of my own. So I'm also actually speaking as CEO of Staff Limited about a project to build a website for safety audits to support some UK legislation. And that's built on top of Wolfram Application Server, which I'll say a few words about as well. So let me give you the background, first of all, to the project. That the EU passed a directive back in 1992 that made employers responsible for the safe use of display screen equipment. And in line with the EU directives, countries passed their own laws to support that directive. And there's a UK law that dates from, I think, 1994 that enshrines that as an employer responsibility. So it's quite a sweeping definition. Display screen equipment is computers, laptops, it can be touchscreen devices, it can be smartphones, but fundamentally, the employer is responsible for ensuring that you can use those safely if they're used for employment for more than an hour a day. And it even includes the kind of environment, the furniture, the chair you sit in while you use the computer. It's quite sweeping. And the basic idea is that you've got to evaluate the risks using a competent person, which is not very clearly defined. You have to then address any of the identified risks that you see. And if you have more than 5 employees, you have to keep records to show that you've addressed those risks. So this is a fairly small task, but it's one of those sort of admin burdens on companies. And I thought it would make an interesting project to try and automate that process to help companies to manage those risks and track everything. So the basic idea is that my tool lets the organization set their own policies for what they mean by a competent person, what level of training that person requires, how often they should be assessing equipment, how quickly it needs to be remediated. It delivers and tracks the training, it delivers and tracks the assessments, and it also tracks the remediation, and it provides some management oversight reporting to see how you're doing. So to give you a sense of what that looks like, before I explain how I made it, let's switch here to jump into the application. So I'm just going to log in here as a test user. And you can see here as a test user, I've got a whole bunch of things I'm supposed to have done here for my organization. I've not been paying attention to it. There's some training needing performing, some assessments I'm supposed to do, some tasks I'm supposed to do. But let's walk through the process first of all. That as a manager, I get some extra things that users don't. I can manage the organization. Here's where I set the policies on how assessment is done, how tasks are tracked. I can do things like customize email text. So when your assessment is due, this is the message that gets sent out to people. And the basic idea is it centers around a training section where there is a mixture of videos to watch. And I'm going to cheat here and skip through to the end of that video. And then formative assessment questions that you get to check whether you've been paying attention and check the answers. And I did a bad job here. Who's responsible? The employer is. All of the above, and I guess that was wrong as well. Check answers, and when I've got everything right, I move on and eventually get an exam that I can't check my results on. Once you're trained, the idea is the assessment is you set up devices. I might have a home computer and a work computer, and then I can do the assessment in a very similar kind of way. I go through and, oh, you can see I've been testing this form, so it's already partly pre-filled, but I have various questions I have to answer. And then if I give a non-compliant answer, I'm asked to fill in details. And those create tasks. And the tasks are then tracked. If I go to tasks here, you can see tasks that I, as the manager, have to do for Bert's got a problem with his keyboard. And I can view that task, add comments, close the task when I think I've done it, and so on. And then the kind of outer layer of that is kind of analysis tools where I can see that actually, this one's a bug, but here is my most popular problem is uncomfortable keyboard. So that might tell me that I'm buying too cheap a keyboards in IT, and who my most awkward user is, who's got the most problems, and so on, show up in these test environments. And what you get to do depends a little bit on your roles. And so as an admin, I can see information about users, but users can't see each other and all of that kind of business. So and these things are on the welcome screen just tie into these other things that we've seen. So if I go into 6 items either attending, I can see the things I'm supposed to do. but I can also look at that from an employee point of view and say, out of all my employees, who's got things to do that are overdue? No one. I don't have to chase anyone, and so on. And this is where I add users or create invitation links. So it's all just automating workflows. It's nothing's spectacularly complicated here, but keeping it all organized and automated is the purpose of the tool. I apologize slightly for the page design. It's still a work in progress, and I'm going to go through the graphic design a bit more later. So let's talk about this from a Wolfram technology point of view. There are several different ways to create websites using Wolfram Tech, which I've kind of summarized here. There's Web Mathematica we've had for years. It's still supported, but it's not the future. So there's 3 choices. I initially implemented this in the Wolfram Private Cloud, which is the private version of the public cloud technology. But actually, I wasn't using some of the main features like, for reasons I'll go into in a bit, I wasn't using the permissions mechanism or cloud notebooks, which are the kind of key features that it has that nothing else does. The web engine for Python is really for kind of toy implementations. It's single-threaded, doesn't scale, doesn't have any kind of high availability tools, but it's very easy to prototype on. So the obvious thing was to migrate over to application server when that became available. So that's kind of rapid deployment, high availability technology. It supports multiple nodes, multiple kernels. The API functions and form functions are supported. In fact, all I needed out of this is the API function, and it's also relatively lightweight. So the technology, the architecture that I went for this is that the entire application almost is implemented in Wolfram language. So when you log in through a browser, you're dealing with a Docker container managed by Kubernetes that is hosting Wolfram application server. The only bit that is not Wolfram in the technology stack here is the database backend that's storing the data. I wanted it scalable, and we don't really do databases at Wolfram, so I've got a MySQL database. And because I don't have scheduled tasks in Wolfram application server, that was fairly easy to have a little side Wolfram script, cron script, that runs once an hour to send out reminders and flush failed email sends and things like that. So now if we kind of zoom in on the application server component, what I'm doing is the entire process from request to response is Wolfram language. So when the request comes in, we extract the parameters from the request. So there might be form values that have been submitted. We fetch information about who you are. There's a whole bunch of business logic to decide what you're allowed to do and which uses these bits of information. And then I construct the entire HTML page and in the Wolfram kernel, in Wolfram language, and I return that in a single blob back to the browser. So the browser just sees, request a website, web page comes back, but all of these 4 steps here, apart from the back end of fetch user data, is all Wolfram technology. So that, I'm not going to bore you with a long explanation of the business logic in here, but let's go through the key components that I had to build in order to deliver us. So as I said, the HTML is generated in Wolfram language, and what I do is I build up all of those pages essentially using XML element. But I'm backing it a little bit with some CSS and JavaScript, and at the moment I'm just using the W3 as the lightest weight, simplest, minimal JavaScript and styling in order to get what I want. I'll probably move over to Bootstrap before I ship the thing because I can make things look a little bit nicer with those. So let's show what this looks like in practice. I'm going to load here the package into my current Mathematica session. And what that gives me in the HTML space is a bunch of functions that I've built to create components that I can assemble pages out of. So these are written, as I said, using XML element. But once I've kind of got them as high-level components, I'm trying to avoid touching XML element at all when I'm actually constructing pages. So I'm trying to construct them out of high-level things like a button, out of an accordion, out of tooltips. And obviously you can see from my design point of view here, I'm somewhat guided by kind of equivalence to Wolfram language constructs. So there's equivalents to things like row, and I guess accordion is an opener view really, but the syntax is a little bit different. So I haven't tried to just convert those automatically. So what these things do, this collection of HTML tools that I built, is that they return the equivalent XML elements. So if I take my little grid constructor here and throw some random numbers into it and some headers, what I get back is this sort of complicated XML element construction I could have written by hand, but would be quite verbose. I then convert that into an appropriate wrapper of HTML, which I'm hoping at version 13 of Mathematica I can throw this out, because we've got some new constructs coming for web page, web row, web column, and web item, which actually will automate some of the things that I've written here. So I'll probably get to throw out at least a few dozen lines of code. But what that does is it converts those XML elements now into XML syntax. So it's done effectively an export string on this with a little bit of conversion of any non-compliant elements it finds along the way to make sure we get valid HTML. So you can see I've got HTML here with a head and some head information, and then the body, and somewhere down here you're seeing the tags relating to my table. And because I've got this tied into the W3 CSS and JavaScript, I can get that style quite nicely. So if I now throw that into embedded HTML of that grid and open this up in a browser, oops, I have opened on the wrong screen here. Let me just move this over here. You'll see that what we actually get now is something that looks like reasonably attractive, subject to some proper styling work to come, HTML rendering of a table. And in fact, I have a whole bunch of options on these commands. So things like whether or not the table is sortable by various columns. So I have the default is that they're all sortable if there's more than 3 rows in them. I default styling to have mouse overs on the rows and the like. And I'm gradually kind of building out the syntax of these functions to try and make them as flexible as possible, so that I never have to go back to raw HTML or XML objects, except in extraordinary circumstances. So once you've got these components, they nest together just like Wolfram language interface design. So if you ignore the preamble to convert it to HTML, I've got here an accordion, which is kind of an opener view, the face of it, and then inside that, I'm going to put a tab view with some tabs, and there's some options for the accordion. Let's look at what that looks like. Oh, that will let me on the wrong screen here. Let me swipe that across and bring the whole browser over. So here's my my accordion, my opener view, and here's my tab view inside. So my aim is really to get to the point where I don't really have to think about HTML or details very often. I just sit on top of these high-level components. And one of the things that gives that is very nice is being able to write HTML in a very kind of functional programming style. So these constructions can sometimes be very compact. As a sort of toy example here, I've got a little function of an accordion, and I'm going to map that over the whole of example data. And in this sort of 3 lines of code, I've made this sort of snippet viewer for all of the example data text that we've got in Wolfram language. So here's the snippet for Alice in Wonderland, here's Don Quixote and Faust and so on. So being able to bring to bear things like map and map thread and map indexed, where the contents are components of HTML, is sometimes really quite elegant, because quite often I get back things that are just a table of data. So I want to very quickly create something that's a viewer for each row and map that down the list. So it's without any kind of iteration, I get to apply these functional things for quite elegant page construction. Actually, as an example here, what this looks like when you are building an entire page here. If I go back down to the actual source code of it, this, for example, is the home page that you saw there, where I'll explain this page API in a moment, but all you see in there is an action widget that's got some text in it, and that's the big question exclamation mark blob that appeared on my welcome screen. And if I go down here to something like the navigation wrapper, I just wrap that around the page. So it's a sidebar containing some buttons that have some permissions control that are, these represent, if we go back to the tool, where have I got my browser? Then that represents this docked cell on the side. The next step is database tools. I didn't need to do this, but I find database link rather clunky because it's a direct mapping to SQL in a kind of very SQL-like way. I really like working with associations in the Wolfram language, so I wrote a thin layer to extend database link to always return associations. So the idea is that I can say get from the users table anything that matches this set of keys, and I'm going to return back all the information I have on the user johnm@wolfram.com, and you can see when I last logged in, and the whole thing's an association. And so I'm routinely getting big blobs of data and then just using the bits of them that I need. Because I'm never having to return stuff to the browser, all of the page construction is, or nearly all of it is done on the server side. I can actually be quite lazy and sloppy with data security, because I can have functions like this get records that I use a lot that just returns a whole bunch of information, some of which I might not ever want to display, but because it never reaches the browser, it's processed on the server-side functions, then I can just throw in information into this association just in case it's something the function will need. And I find that's a really kind of nice, lazy way of coding. At some point when we have writing through entities, I'll probably switch over to that, because the entity system backed by databases is very elegant, but only for reading at the moment. And this is bidirectional, so I've got an update equivalent that says update the user that with this information where I'm looking up the user that matches these keys. So it's saying the user whose email is johnm@wolfram.com changed the phone number to 000, and now when I do get records on that to pick out the phone number, you can see it's been updated. But really behind the scenes, this is basically just a database link from the kind of standard Wolfram package. Little bit more interesting though is authentication. So I need to authenticate users and give them privileges according to their usage. I didn't want to use the kind of Wolfram ID type mechanism, because I end up then having to manage credentials separately from information about the user. I didn't feel like I could then be in charge of things like password reset without reaching into the database that's on the EPC to reverse engineer how we store Wolfram ID information, all undocumented and not a good place to go. So I decided to handle authentication entirely myself. So let me walk you through the process of that. First of all, obviously there has to be a login. Well, now that I've got this high level language for pages, this is basically what the login page that you saw was. It's just sometimes I return error messages back to the page to say wrong login or whatever, but basically it's some inputs that correspond to HTML type inputs, or tooltip explaining what to do, and a link to send a password link that goes somewhere else, and then it's a form. So that's pretty trivial. I then check the person's password against a hash of their password in the database. So trying to be good practice, I don't store passwords. And what you get back, if you can verify that, is we need something to be able to manage the rest of the session. Now, it turns out that handling cookies in Wolfram Application Server is a little bit awkward for legacy reasons that are for security on EPC, and that don't actually apply to Application Server. And I hope to get the design changed on that at some point if I can persuade the people who do this. But it turns out I don't need to jump through hoops to send and receive cookies, because I don't need persistent logins. And there is one cookie that I do have access to, which is managed entirely automatically for me, which is a Wolfram Application Server session ID. So as soon as you hit the application server, it sets up a session ID so that it can manage whatever it needs to manage. And it turns out that's all I need to do to be able to manage your session. It's good for 15 minutes of inactivity, and I want you to log in after that time anyway. So what I do is, after I verified the password, is I take the session ID that's already been set up for me, and I store that against your user ID, so that if you return using that session ID, anytime in the next 15 minutes, then I know who you are without having to ask you to authenticate. So here's what that looks like. I've stripped out most of the error checking, so the actual code's a little bit more verbose, but this is all the important bits. So the login command takes the values from that form. It looks up the user with that email address. If it can't find them, well, if something goes wrong or it can't find them, then you get a failure. Then what we do is we compare the stored password hash against, and I do a hash here that I'm not revealing the algorithm, but it's basically sits on top of a standard hash to scramble the email and password so that in the same way that was stored previously when your password was set up. So if that matches, your password is good for the user that you are. If it's not, we've got a failure. Otherwise, update the record to say for that user, they last logged in just now, and the session ID, and here's how we capture from the browser the Wolfram application server session ID. It's in the headers of the HTTP request that came in with this last API call. So we grab it out with this HTTP request data session ID, and you get a 10 or 12 digit number, something with enough entropy that it can't be guessed. And I salt and hash that for storage for later comparison in the rest of the session. So that's pretty much the whole login session management, apart from how I consume those sessions later. So when you come back, we read the session ID again, and we look that up at the database to see if we know who you are, whether you have an active session currently running. We also, I time those out after a period of time, so you can't systematically go through very old sessions. And here's the process. Every page goes through is the first thing I do is I find out information about who you are, which is this command gets used all over the place in the system. Again, I've stripped some of the error checking here, but basically it gets session ID again. I actually do have to revert back to an SQL select statement here because I'm doing a join. I've never implemented a nice join mechanism for my thin layer on top. So we're going to get from all of the columns that might be interesting across the users and organization table, all of those rows, all of those columns rather, where the session ID matches the resorted hashed session that you've just declared, and with the extra check that we can only fetch information from the organization ID that matches the user. So this is policies that might relate to you set by your organization, but we don't want to cross, they've got to be linked so that we don't get other people's policies. And that's it. I now know everything about you the moment you return to the page. So then the next thing is, what do I do with that information? You arrive on the page, I know who you are. As I said, there's no permissions mechanism. When you do cloud deploy in Wolfram EPC or the public cloud, there's this notion of permissions. Is it public? Is it private? Is it this user's? And so I created my own permissions mechanism to consume the information I've just returned. And really, it just mirrors the built-in permissions mechanism in the cloud. So I created this authenticated API. It takes parameters, a function to apply, and a permissions function. So it's a function here that is applied to the user information. So we fetch the user information, we shove that into the permissions function. This is what that looks like. This is my user ID here, and I can see I have permission to view billing. So I have a collection of these various permissions that I've abstracted out of. Are you allowed to use the system at all? Are you allowed to use the bits of the system that are paid for only? Are you allowed to see other people's information in your organization? I guess view billing is one of the higher privileges that when this is a commercial application, that's seeing how much money you've paid. And I can see that as the admin for this site, I have that permission. So here's what a typical page looks like. I have an authenticated API. It has some parameters like anything that might come in from a form, maybe no parameters. Here's what the page does. In this case, it just returns a string that has whatever the message passed in joined to the username of the user ID. And you'll notice here, message is part of the parameter set, but hash user ID isn't. I have access through the functions that this takes have access to any key that gets returned about a user or about their organization. So I can just immediately reach into that and say, I want a page which has the user's name on it simply by referencing that key. And I've put a permission mechanism on here that they have to be authorized against active. So that means not somebody who has been disabled by their or deactivated by their admin. So the idea is that if an employee leaves, the admin can remove them from the system, and they shouldn't be allowed to log back in and use the system. So this is saying this page will say, let's say I call this with the parameter of hello. This will say hello, John, if John is allowed to use the system. So I end up with a very kind of elegant way of course, this would be using my HTML tools to construct the page and return the whole thing as beautiful HTML, not a raw string as this example does. So those are, apart from all of the business logic, those are all of the kind of core bits of functionality that it sits on. At some point, I might wrap up the HTML tools into something that I release as public, because there's nothing particularly proprietary to my application on that, although some of the styling might end up being rather tied into my view of what's beautiful. And the authentication stuff is really, apart from error checking, is no more than I have just shown. So the final step then is deployment. Now, Wolfram Application Server is, you deploy to that a little bit differently than EPC. The installation is much, much simpler. You essentially do a git pull, and then you run a Docker command, and in a couple of lines of code, you have installed your, you copy down a script, and you run the script basically, and it installs it onto your Amazon, or in this case, I'm running it locally on my Mac laptop. Although I have a version that we're testing out, I'm using the Wolfram Research Europe employees as a test set of guinea pigs for the tool, and they've been using it for a few weeks now. So I have that running on a little Linux server within our office. The way you deploy in is not through Cloud Deploy on Wolfram Application Server. Once you have your application server running, you load a client package, which I don't know if it's now built into 12.3, but it was a separate package when we were at 12.2 when I started playing around with this. So I had to install it once, but now you just say load the extension to Service Connect, and then Service Connect will reach out to, in this case, I'm running on localhost, a connection to the Wolfram Application Server, and this is now a handle to talk to the application server. So all of these APIs, all of these pages are essentially either static or API functions. The API functions get deployed like this. You do your service deploy to the application server. The content is what gets returned from my package, the API function that gets constructed, and then basically the page name, where it gets stored and where it gets served up to are different for sort of DevOps reasons, but at the moment I'm just deploying to the identical thing here, and then I have to say it's active. So it's an API function. It will use a Wolfram kernel when this page gets hit. And the static elements, things like the video, they get deployed in almost the same way, except they are static web elements, so you don't waste, if you don't want to be streaming a video through a Wolfram kernel. For a start, it might create kind of a speed bottleneck, but you don't want to be tying up Wolfram kernels doing trivial things that are never computational. So if the page is purely static, so resources like the CSS and any JavaScript files, the videos, static images, these things are all deployed in the same way, except instead of active web elements, they're deployed as static web elements, and that tells the server just serve them straight to the browser. And then what I do is I have a script that pulls all of that together. So this is how I deploy the entire site when I've done an update. I connect to my production machine instead of my local machine if I'm moving out of a test to production stage. I pass it some parameters, so there's a bit of configuration information on where its database is that the package needs to know. I could have hard-coded those in, but then it makes it hard for me to deploy in different locations and have it work. So I pass that in as a parameter. I pass in mail settings as a parameter. At some point, I intend the user to be able to provide their own if they want to relay through their own server, but this is partly because I have secret information in there like passwords, so I don't want to have those written into revision management, so I pass those in as a parameter. Sorry, that's where the website the thing is on, and this is where the database lives. So actually I can run that now, and you'll see what you get is my deploy all basically maps a service deploy, one of these commands, this service deploy command, over a list of all of the APIs that it's got And so it takes about 10 seconds to deploy the entire site. So when I make code changes, I can quickly host them on my laptop, open the browser, and start exploring to see if they've worked straight away. You can see there's a page here for every one of these active pages. Actually, there's a few more things deployed that I don't display here, that all the static elements I don't bother to list out, but these are all of the APIs that do things like there's an approve user API when I'm an admin and somebody has said, I'm part of your organization, honest. If I've set the policy, it tells me that they're waiting approval, and I have a little API where I can connect and say, yes, that person is allowed to consume my my credits for users on this application. And so all of these serve a different purpose within that business logic. So I hope that's given a reasonable tour. So just in summary, hopefully it was all fairly clear that the whole site, apart from the use of, so the whole site is Wolfram language apart from the SQL database that's backing it. All of the scheduled tasks are triggered by cron, but they're running a Wolfram script that actually calls the same package. And all of the pages are just served up as these API functions or static files that are constructing the HTML and delivering it in one piece. So the advantages from my point of view, obviously, admittedly, the top advantage for me is I have spent many years in Wolfram language, and I can write code far faster in Wolfram language than I can in JavaScript or HTML. So that's my language of choice. May not be everyone's, but some of these things are hopefully agnostic of that. That this does mean that I can work in a single language once I've got my base layer set up for the content, the logic, and the data, that I'm never having to kind of switch syntax and think in different paradigms. That once I got past the first couple of weeks of setting up infrastructure, I'm kind of in Wolfram language all the time. And that means things fit together nicely, that I'm not having to kind of shift gears in my brain as I switch between different things, and one place to log and debug and so on. The ability to describe bits of the page symbolically is a nice way of building up reusable components. Now, I know that's one of the key things that web frameworks give you. Things like React allow you to build reusable components, but we're getting the same kind of benefits almost sort of for free as a secondary effect of this. The fact that I have a description for page components immediately makes it possible for me to design a nice component that's things like a checkbox that opens a give details button if you say no rather than yes. And then once I've got that, I can just use that as a single command, just like any other language within the logic or the page construction. Functional and rule-based programming, all of those nice things about the Wolfram language now come to bear on things like page construction. And as I said, because I'm keeping all of the logic, I'm not making APIs that reach in to fill a bit of the page. I don't have to worry about making sure that API only returns a certain piece of information. I can have functions that are quite careless about their data because it can never reach the clients. And I have a careful, if anything looks like an association, the page splats in case I've screwed up and sent something out of a function that shouldn't be. And as you see, it's a work in progress. There's still a bit of design work to be done and some wrappers around it and some marketing pages to be written. But my hope is that at the rate that I'm going at, sometime soon in the new year, I'll have the thing ready and actually deploy as something that maybe will attract some customers. And if nothing else, we'll run Wolfram Research's European office for the next few years to make sure that no one from having bad keyboards or chairs or whatever other things that a company might get sued over by employees who have injuries working with equipment. So I hope that's given a perspective on how to do a project that is not your kind of usual computational project. Now would be, if you haven't already, I'm going to switch back to the chat here so that I can find any questions that you have. And I'd happily take the questions. Type them into Pathable. There is an area over the right-hand side, and I see there are a couple of questions waiting already. So from Bob is, the application server set up so that database link is already loaded when the request is received, or you have to load it at each request? So if I go back to, I don't know what a good example is here. I built something just for bookkeeping here, which is SQL session block. Oops, maybe I should have opened the definition here. So SQL, oh, well, here's a use fit. So I use this thing as a utility that I created that is like block. It localizes the symbol con. It opens the connection, does whatever is inside the SQL session block, and then cleans up after itself by closing the connection. Because I have experience in the past, if you are lazy with closing connections, eventually your SQL database says there's too many connections open. So I didn't want to have to remember every time. So I used this SQL session block everywhere to say open a connection, do some things that use to share the connection and close the connection. And at some point, I'm going to add an option to this to be able to do transactions as well for sort of guaranteed everything happens or nothing happens type transactions. Would it make sense to create so Francisco asked, would it make sense to create a package that developers could use as authentication user management for Wolfram application server? Yeah, I did. I have thought about just making the authentication part of this a separate package and just sticking that in something like the resource, the function repository, or the new Packlet repository that's coming. I probably should. Actually, the main reason why I didn't think about it seriously was once I'd intellectually solved the problems, it's not actually very hard. I've shown you all of the magic. It took me a few hours to think it through, but actually the coding of it, once you get the basic ideas, and once I rejected the idea of setting my own cookies and passing them back in, it's fairly straightforward. But yeah, I probably should make that something that can be a package. And as I said, I will share the HTML tools at some point when they stabilize, but I think they're probably less useful because they're a bit personal. Rodrigo has asked, can you share the notebook? I will have to do just one check to make sure I stripped any sensitive information that I had iconized out of sight. And then I guess, I don't know if, is Darren still listening? Will they show up in the file section of this area in Pathable if I share them?
Yes, you have a manage option where you can upload files.
Okay, so come back in half an hour or so. I'll make sure the final version of this talk notebook is back on this files tab of this session. Right, and I think that seems to be the last of the questions. And last chance if anyone wants to. Did I miss one? Oh yes. Sorry, it scrolled hit outside. Have you? So Jesse asks, have you built or found yourself wanting any sort of continuous deployment system for deploying Wolfram language source code changes to your application server environment? I haven't yet. I keep edging towards slightly more automated steps. So I've actually on one of my, I have a development, test and production set of machines. The function I actually showed for doing the deployment is how I do that for the development and the production machines. I've actually already started experimenting with something that is a little bit more hooked into Git. So all I have to do is do a Git push and have it automatically deploy the latest version on that branch. But I haven't quite completed that. I have to say at this point, it's I'm not working with a team here. I know exactly when things need updating and deploying. And I know exactly whether they've been high risk changes and low risk. So the idea of having a constantly live version isn't so useful. Yeah, so the demo is running actually just straight on Docker on my laptop. So, you know, somewhere up here, I've got Docker desktop running, and here's the application server just running straight within Docker. So, you know, obviously I need the Kubernetes scaling. If it's ever going to be successful, I need to be prepared at least for scaling on the production server. But here on test, I just run it straight here within Docker desktop on my Mac. Okay, any others? Did I miss any at the beginning? Rodrigo asked, Web Engine for Python is the same as Wolfram Engine for developers. Now you're testing me on our branding. Wolfram Engine for developers is the generic Wolfram Engine that can be deployed in a bunch of ways, such as Wolfram script and other environments. The Wolfram Web Engine for Python uses a Wolfram engine to do its computation, but it's a set of Python scripts that serve up a single-threaded server that just runs off it off a set of files locally on the machine. So you can think of the web engine for Python as being a combination of some Python web server tools and a Wolfram engine. So they're not strictly exactly the same thing, but they kind of amount to the same thing. Well, thank you very much, and enjoy the rest of the conference.